Good afternoon, students. In the previous sessions, we have completed this current electricity chapter. Next, tomorrow I am going to discuss some of the previous appeared questions in the CBSE as well as state syllabus exam papers, and some other important questions I will discuss today. Okay. First, this is one of the previous appeared question in CBSE board exam. Now here, question is. Two wires A and B are equal length, have equal resistances. If resistivity of A is more than that of B, which wire is thicker and why? This question includes multiple questions here, sub questions. First question is two wires are given, one is A, another is B. Length is equal. Here length of wires are equal, that is LA equal to LB. Length of two wires are equal. Students, hope you remember this current electricity chapter from the beginning, starting from this Ohm's law, resistance, concept of resistance from Ohm's law, V is equal to IR, and resistance, dependence of resistance, R is equal to rho L by A. We have this equation, resistance R is equal to rho L by A, where rho is resistivity and L is length of the wire and A is cross-sectional area of the wire. Now in this next concept we discussed is after resistivity, resistance, it's a combination of resistance, then electrical power, electrical energy, etc. Many concepts we discussed, and power, combination of resistors, all those things we discussed. All type of questions appeared here based on all the concepts. Now first I have taken here, this is a CBSE board appeared question. CBSE board appeared question here. Now this includes multiple, this is a 5-mark question, 5-mark numerical. Here two wires, first I take A and B, equal length I have taken, and equal resistance, that is the resistance of A is equal to resistance of wire B, right? Resistance of wire A equal to resistance of wire B. Now if the resistivity of A, what is the resistivity? Resistivity means rho here, symbol. Resistivity of A is more than that of B. What they are given is resistivity of A is greater than resistivity of B, correct? Resistivity of B. Then which wire is thicker and why? Reason also they asked. Which wire is thicker? Thickness, that depends on cross-sectional area, right? Thickness depends on cross-sectional area. How to represent area? Here area is equivalent to pi into r square. Pi into r square. R is the radius. R is proportional to diameter, or R is equal to diameter by 2. Now if area is more, area of cross section is more, if area of cross section is more, then we can say it is a thicker. Area of cross section is less, area is thin. Now using this resistivity formula, I will modify this. I will write as rho is equal to RA by L. RA by L. Now what they are given is length is same, resistance is same. Length and resistance of two wires are same, so that we can say length is constant, resistance is constant, so that resistivity is directly proportional to area, we can write. According to the given question, resistivity depends only on area here. It is independent on resistance and length. So that if you write rho is directly proportional to area, if resistivity is high, means area of cross section also high. That is, from this we can write rho is higher here, resistivity for A, so that area of A is greater than area of B we get, because resistivity is directly proportional to area we get. This is the answer for first question. Your answer for first question is which wire is thicker? Which wire is thicker? That is thickness of area. Area, this A. A is thicker than B. Wire A is thicker than B. This is the answer for this first question. Why reason? Reason is radius, and resistivity is directly proportional to area. That is the reason here. Yes, rho is directly proportional to area, so that resistivity of A is high, so that thickness of A is high. A is thicker than B. That is the reason for this question. Why? Reason is rho is directly proportional to area. Is it clear? Next, another sub question here. For the electric circuit given below, this circuit is given. This electric circuit is given. Resistance here is, I'll write this as R1 is 30, and R2 is equal to 10 ohm, and R3 is equal to 5 ohm here. 5 ohm. Three resistors given here. Three resistors. I'll write this as R1, R2, and R3. Here question is current in each resistor we have to find, total resistance we have to find, and total resistance is the equivalent resistance we have to find. Then total current drawn from the battery, total current drawn from the battery. All these parameters we have to find. First I will find equivalent resistance. Equivalent resistance. Once we get equivalent resistance, then we can calculate this current and this current in each resistor easily. Is it clear? First I will find equivalent resistance. How to get equivalent resistance? Here three resistors are in parallel. Correct? Is it clear? Someone is saying resistance is inversely proportional to thickness of the wire. Yes, resistance is inversely proportional to thickness. That is correct, no? That is given here. Someone who is that Rekha Jan. See, it is given here. It is correctly given here. R is equal to rho L by A. It is given, and resistivity I given here. Resistivity modification. Rho is equal to RA by L. I have modified that relation. Please understand this concept. A rearrangement of the equation. Then I wrote using this. RA is equal to RB and LA is equal to LB, I can write resistivity is proportional to area. Otherwise, the resistivity of a given conductor, that is a constant, right? Resistivity is independent on a cross-sectional area, or it is independent on the length. Okay. For this specific question, we can write rho is proportional to area. Now here equivalent resistance I will find out first for this circuit. Three resistors R1, R2 and R3 is given here. R1, R2, R3. What is the equivalent resistance? 1 by R equivalent is equal to 1 by R1, 1 by R1 plus 1 by R2 plus 1 by R3. Three resistors given. Three resistors given. Three resistors given. A substitute here. If you substitute this value is 1 by 30, that is 1 by 30 plus 1 by 30 plus 1 by 10 plus 1 by 5, 1 by 5, 1 by 5. Simplify this, you are equivalent resistance is 3 ohm. It is a parallel combination. Parallel combination is not 30 plus 10 plus 5. It is a parallel combination. It is not 30 plus 10 plus 5. Someone is wrong there. First you take this LCM and simplify LCM and simplify equivalent resistance you should find. And once we get equivalent resistance, total current drawn from the battery we get total current drawn from the battery. Equivalent resistance, I will use calculator here. 30 into 10 into 5 denominator. Students, please solve this. It is 30 into 10 into 5 here, and here first if I take a first 30 here, 10 into 5, 10 into 5 plus 30 into 5 plus 30 into 10, 30 into 10, and then take reciprocal, simplify this, simplify. This is 1 by R equivalent, 1 by R equivalent. Reverse this. Is it 3 ohm? Written someone 3 ohm. Is it correct? 3 ohm. I'll find out first. 10 into 5, 50 plus 3 into 5, 150, 200, 200. This is 300, 300 plus 200, 500, 500 divided by 30 into 10, 300 into 5, 3 into 5, 1500. That is 3, right? R equivalent is, that is R equivalent is equal to 3 ohm we get, correct? Yes, some answered correctly. Equivalent resistance is 3 ohm we get. It is 1 by 3 here, 1 by 3, 1 by 3, and this is R 1 by R equivalent, 1 by R equivalent, so that reciprocal we get R equivalent is 3, right? Yes. R equivalent is 3. That is the answer for last question. What is the equivalent resistance of the circuit is 3 ohm we get. 3 ohm is the equivalent resistance. Next question is the total current drawn from the battery. Here battery of 6 volt here, 6 volt, correct? 6 volt battery is given. Total resistance is given. Then what is the total circuit current I? Total circuit current I. This I have to find. How to get I? Total circuit current I. I is equal to, this question, I equal to V by R equivalent, total resistance. What is V? I is the total, is V by R equivalent. R equivalent is already calculated, that is R equivalent is 3, right? R equivalent is 3. So that what is the current? 6 is there, 6. 6 by 3 we get 6 by 3. 6 by 3. Is it clear? 6 by 3. I is equal to V by R. 6 by 3. 6 by 3 is a 2 ampere we get. 2 ampere. 2 ampere. Someone got 0 0.3. How it is? So 0 0.3. Yes, 2 ampere. Is it correct? Next, current in each resistor I have to find. Current in each resistor. How to get current in each resistor? This current I will write as a I1. This total current at this junction, what happens? Students, look at here. This is a junction. At this junction, this current, total current I splits into 3 branches, right? Splits into 3 branches. This I will write as I1. This I write as a I2, and this I will write as a I3. Okay, 3 current I get. 3 currents. I1, I2 and I3. First I find I1. How to get I1? I1 is equal to, I is equal to V. Now students tell me, what is the potential difference across each resistor here? It is a parallel combination. Parallel combination of 3 resistors, right? If 3 resistors are in parallel, potential difference across each resistor is same. Here 3 resistors in parallel, so that voltage drop, potential drop across each resistor is same, that is a 6 volt. Is it clear? So that I1 I can write as V divided by resistance R1, resistance R1, and I2 equal to V by resistance R2. I3 equal to V by resistance R3. Is it clear? V by resistance R3. Voltage is same. Yes, voltage is same. Resistance is different, so that current I1, I2, I3 is different. Now I get I1, I2 and I3 here. Now V is 6, that is common here, 6 divided by, what is the resistance here, 30. 6 by 30, 6 by 30 is 1 by 5, 1 by 5, 1 by 5 is 0 0.2, right, 0 0.2, 0.2 ampere here. Next to V by R2, V is equal to 6 by 10, 6 by 10, 6 by 10, how much? 0.6 ampere, 0.6 ampere. Next V by R3, 6 by R3 is 5, 6 by 5, 6 by 5 how much? 1.2, right, 1.2, 1.2 we get 1.2 ampere. Students, tell me what is the total current? This total current must be this I, correct? This I1 plus I2 plus I3, that must be equal to I here. Total current I equal to I1, I2 and I3. Now 1.2 we get 1.2 here. 1.2 plus 0.6 plus 0.2, total we get 2 ampere here. 2 ampere. This 2 ampere is the same as the supplied current I. That is I is equivalent to 2 ampere, right? I equal to 2 ampere. Here total current we can write as I equal to I1 plus I2 plus I3. If you substitute and simplify, we get 2 ampere. That is same as this supplied current by this battery. Is it clear? Students, is it clear? Any doubts here? Any doubts in this question? Yes. No doubts. Shall I move on to next question? Yes. Here is a next question. Electrical lamp. An electrical lamp resistance is 20 ohm. Resistance is 20 ohm. Now this is a lamp here, this electrical lamp. This electrical lamp has a resistance. This resistance of this lamp is R is equal to 20 ohm. And a conductor of resistance 4 ohm. This is a conductor of resistance 4 ohm. I'll write this as R1 here of 4 ohm here. 4 ohm. R1 is 4 ohm. And this is R2. I'll write R2 is bulb of 20 ohm resistance. Are connected to a 6 volt battery. This is a 6 volt battery here, connected as shown in the circuit. Now to calculate this 4 parameters here. First one, question A is the total resistance of the circuit. Total resistance. Students, total resistance. What is the total resistance here? Directly you get here R1 and R2. This is a resistance wire. This is a resistance wire here. This resistance wire and bulb in a series. In a series combination of two resistors. What is the equivalent here? Equivalent to first question. First question answer is R equal to R1 plus R2. We get 4 plus 20. That is 24 ohm is the equivalent resistance. Yes, that is correct. 24 ohm is the equivalent resistance. Next question is the current through the circuit. This also you can calculate, direct calculation, as we solved in the previous classes. Similar question, current through the circuit. Please solve this, current through the circuit. How to get current? Total resistance is already calculated. Battery voltage is given. Battery voltage V is equal to 6 volts. By using 6 volt you get current. What is current? I equal to V by R equivalent. R equivalent is 24. What is the current to the circuit? Using V is equal to IR. Second question, I'll write answer here. V equal to I into R, Ohm's law. V equal to IR. Someone given 0.25, someone got 2.5. It was calculated in the reverse way. I is equal to V by R. V by R. Current V is 6 here. V is 6. R equivalent is 24. That is 1 by 4. 1 by 4 is 0.25 ampere. 0.25 ampere, right? 0.25 ampere. This is the circuit current. Main current I is equal to 0.25 ampere is the circuit current. Yes. Next, one more question is C. The potential difference across the electric lamp and conductor. Separately, we have to calculate. Electrical lamp, this potential difference, I will write this as a V2, and resistor I will write as a V1. V1 and V2 I have to find. How to get to V1 and V2? Direct calculation. V1 and V2. How to get to V1 here? V1 is the voltage drop across a resistor here, wire. That is a question C. V1 is the voltage drop across a resistance wire, and V2 is the voltage drop across this bulb. Now V1 and V2 I have to find. See students, since these two devices are in series, then what is the current through each device? That is equal. Current through each device are equal, right? Current is equal means current is same, so that V1 is equal to I into R1, V2 equal to I into R2. We can write V1 is equal to I into R1, V2 is equal to I into R2 using Ohm's law, right? Now substitute here. I is common, that is 0.25 into what is the resistance R1? Resistance R1 is 4. 0.25 into 4, how much? 0.25 into 4, that is 1, right? 1 ampere, sorry, 1 volt, it is the potential difference. 1 volt. Here 1 volt drop. Next, what is the voltage drop across R2? Voltage drop across R2. I is same 0.25. What is the resistance? 20 into 20. 20 into 0.25, that is 20 into 0.25, how much? It should be 5, right? 5. It should be 5 volt. 5 volt we get. 1 volt and 5 volts. You cross check, is it correct or not? Cross check here. See, what is the supplied voltage here? Supplied voltage is 5, right? Sorry, 6 volts. 6 volt is the supplied voltage, and these two devices in series, total potential drop is V1 plus V2. In the previous problem, current must be same because they are in a parallel. Here it is in series, so that voltage, total supplied voltage must be V1 plus V2. It is not in our given question. It is additionally I am giving this question. V1 plus V2. What is supplied voltage here? Supplied voltage is a 6. V1 plus V2, how much we got? 1 plus 5, that is a 6 volt. So that our calculation is correct. This is a cross checking. You have to cross check after getting your answer. If you cross check your answer once again, then you can understand whether it is correct or not. If any mistake is there, you can rectify that. This is a question C. Electric lamp and conductor, both we already calculated here. Next, power of the lamp we have to find. Power of the lamp. How to get power of the lamp? Power of the lamp. Question D. Question D. How to get the power of the lamp? Power of the lamp. How to get power? Anyone calculate this? Voltage drop is there. resistance, we can use both the formulas. P is equal to V into I we can use, or P is equal to I square into R we can use, or P equal to V square by R. Three equations are there. I'll write here three equations. P equal to Vi, basic equation. Another equation is I square into R, or P equal to V square by R. Using these three equations we can find. All data is given, right? All data is given here. Voltage we calculated, resistance we have, and current through this bulb also we have. So that any of these three equations we can use. In all equations we get the same answer. 1.25 watt someone given here there. Is that correct? Someone that is a 5 watt. What is the correct answer? I'll write V into I. V is what is V2? V2 is 5. If I use this equation I can write V2. V2 is 5 into V2 is 5. Current is what is current? Current through this bulb. Current I have calculated somewhere. I is equal to 0.25. 0.25. That is 1.25. Correct? 1.25 is given S. 1.25 watt. Yes, 1.25, 1.25, not 1.5. Some are given as some of your answer 1.5 is given. This is 1.25, right? This is correct answer, 1.25. See, students, you notice this one here. This additional calculation I given. This is in a series. So series, in a series combination of any devices, not only this resistor or bulb, any devices, current is the same, but total potential difference is the sum of voltage drop across each device. Correct? In a previous question, you check this previous question. In a previous question, see, I1 plus I2 plus I3, total current is equal. That is a sum of the current in a parallel combination. Is that clear? Yes. To take next some questions here. Next some questions. See, these are this also some appeared questions. Very important appeared question in your board exam. Okay. First, I take a 17th question here. Calculate the resistivity of the material of a wire. Length is given, length of the wire. First, I calculate the 17th question here. Question number 17. Length of the wire is given, L is 1 meter, and radius is given. Radius is, I'll write a small r. Radius of the wire is 0.01 centimeter. I'll write this as 0.01 into 10 power minus 2 meter. Convert into SI system, meter. Next, resistance is given 20 ohm. Resistance is 20 ohm. Okay. What I have to calculate? Resistivity rho I have to calculate. This is a question. This is a appeared question in a CBSE board. Appeared question. Okay. Question is not visible. Question is not visible properly. Say, I'll read. Calculate the resistivity. Question is calculate the resistivity of the material of the wire. Length is given. Length is 1 meter. Radius is 0.1 centimeter. And resistance is 20 ohms. Resistance is given 20 ohm. I have to find the resistivity. How to get resistivity? Rho is equal to RA by L. Correct? RA by L. That is RA by L. You substitute here data. Area is how to get radius is given. Using radius we get area. How to get area? Area equal to pi into r square. Area is pi r square. I'll write this as 0.01 into 10 power minus 2. See, for calculation point of view, this is 0.01 into 10 power minus 2. I'll write this as area pi into, I'll write somewhere here, radius conversion equal to 0.01 into 10 power minus 2, or meter is a radius. For a simplification point of view, in all questions we have to convert this 0.01 into 10 power, so that easily you can square or multiply. This I will write as 0.1, I will write as a 10 power minus 2, right? 0.1 means 10 power minus 2, 1 to shift to 10 power. This I can write as 1 into 10 power minus 2 minus 4 meter. Is it clear? This is 1 into 10 power minus 4 meter. If I substitute like this, here I can easily solve. I can solve. Area, that is pi is 3.14 into r square. R square I substitute as 1 square is 1. 1 into 10 power minus 4 square, that is 3.14 into 10 power minus 4 square is 10 power minus 8. 10 power minus 8. 10 power minus 8. You substitute that value of area here. Radius, resistance is 20. Area already calculated, 3.14 into 10 power minus 8. Length is given, length is 1 meter. This is 20 into 3.14, 20 into 3.14, 20 into 3 is 60. 60, you multiply this, so 1 4 is 28, that is 62.8 we get, correct? 62.8 into 10 power minus 8. Students, what is the unit of resistivity here? Unit of resistivity, right? Unit of resistivity, ohm here, meter square meter, ohm meter. You should remember all these parameters. It's a SI unit, everything. 62.8 into 10 power minus 8 ohm meter is the resistivity. This is the answer for question 17. Question number 17. Question number 17. Is it clear? Any doubts? Any doubts here? If you have any doubts, you can ask here. I will try to clarify. Okay. If no doubts, I will move on to next question here. That is a show how would you join 3 resistors. See, if that question is clear, I will read the next question. Show how would you join 3 resistors. There are 3 resistors, each of resistance 9 ohm. See, students, what they are given is, there are 3 resistors. Question number 18 here. 3 resistors. Each of resistance is 9 ohm. That is, I will take 3 resistors A, B, C. That is RA, resistance of A, resistance of B, resistance of C. That is equal. That is a 9 ohm. 9 ohm. All are equal. That is given. Okay. How we have to connect this, so that equivalent resistance of the combination is 13.5 ohm we have to get. First question is, in that question 1 is equivalent, R equivalent should be 13.5 ohm. To get 13.5 ohm, using 3 9 ohm resistors, You have to make a combination so that equivalent must be 13.5. Okay, that is the first question. Second question, we have to get a 6 ohm. Now, how to get 13.5? You know that in a series combination of resistors, total resistance always greater than the minimum value of resistance, increases total resistance. In a parallel combination, total resistance or equivalent resistance decreases in a parallel combination. Now, suppose I have to take 3 resistors here, 9 ohm each. If I write, first I will try this combination. If I write 2 resistors in parallel, each of 9 ohm, 9 ohm each, what is the equivalent of this? What is the equivalent of this? Identical, 2 identical resistors in parallel combination. R parallel is R by N. R series is N times R, correct? N times R. All of you remember this. Now, if I connect two resistors in parallel, what is the equivalent of here? 9 and 9, 4.5 I get, 4.5, yes, 4.5. Now, what one more resistor I have to connect. How I can connect one more resistor? Series, this is of 9 ohm. Now, what is the equivalent resistance of this combination? Here, equivalent of this two parallel is of 4. This is a 4.5 ohm, 4.5 ohm, and this is 9 plus now series, right? 9, it is series. Now this 4.5 and 9 is in series, so that R equivalent is 9 plus 4.5, that is a 13.5, 13.5 ohm. That is the answer. Is it clear? This is how we can solve this first question here. First question. Answer for first question. The answer for first question is 13.5 we have to get. How we connected? What is your answer? You have to write conclusion. You have to write conclusion. It is a CBSE board question. This is a CBSE board question, a period question. You have to write two resistors, two 9 ohm resistors in a parallel and one in a series to it. One in a series, so that equivalent we get 13.5 ohm. This is the answer for this 18th question in that first sub question. Okay. Next, second question is a 6 ohm is given. 6 ohm. Equivalent is a 6 ohm. We have to connect the same 9 ohm resistors we have to use. Same 9 ohm resistors. 3 resistors combining, we have to get equivalent 6 ohm. Please try that. How to connect? How to connect? Question is same. 18th question. Second one. R equivalent should be 6 ohm. We have to get. Correct. Is it clear? Try how to get. If I write two resistors, I will try here. If I connect two resistors in a series, 9 ohm, 9 ohm, what is the equivalent? Equivalent is RS equal to 18 ohm we get, 18 ohm, 18 ohm. But we have to get a lower value, that is a 6 ohm, we have to get 6 ohm. 2 in series, 1 in parallel. If I write another parallel here to this is a 9 ohm. Now this equivalent, this I will write as a single resistor, 18 ohm here, 18 ohm here, and then 9 ohm here, 9 ohm, 9 ohm. Is it clear? These two parallel, what is the equivalent? Rp equal to 18 into 9 by 18 plus 9, 18 into 9 by 18 plus 9. Please check this, how much? 18 plus 9 is 27, 27, 18 into 9, 18 into 9, how much? 18 into 9, 160, how much? 162, right? 162, right? 162, right? 162, 162 by 27, 27, that is 6 ohm we get, 6 ohm. Now what should be your answer here? Answer is question, depending on the question. Question is, how would you join 3 resistors, each resistance of 9 ohm, 9 ohm to get equivalent? That is equivalent. How? That is answer is, you have to connect, two resistors in a series, and third one is parallel to that, two series resistors. This is how we can conclude this question number, right? Next I will go back to previous question sheet, that is explain the use of electrical fuse. Next question is 19th question. Explain the use of an electric fuse. What is the use of fuse? Use of fuse. In all the circuits, we have to use a fuse. Fuse is a circuit protecting device. Use of fuse is a circuit protecting device. In your house also, in your home, near a main switch, there will be a fuse that protect if any high current comes. If a high current comes in the mains, then that fuse will melt, circuit will break, circuit will open, so that it saves our costly equipments in our house. That is the use of fuse. Use of fuse is it is used as a circuit breaking device or a circuit protecting device. Now what happens here, when high current comes, that fuse wire will melt. As fuse wire melt, circuit will break out. As circuit breaks, no current will pass further, high current will not pass to your device, so that your device will save, correct? Device becomes safe. What type of material is used for a fuse wire and why? That is the question. What type of materials used in the fuse wire? What type of materials used? Alloys. Usually alloys are used, correct? What type of materials used? Usually this lead and tin combination, alloys. Tin and lead. Tin and lead alloy. Tin and lead alloy is used. Most commonly tin and lead alloy is used. That is the most common material used. It is a alloy. Not direct wires are not prescribed because of a lower resistivity value. Now why reason is, reason why is, what is the reason? What should be the reason here? See, I'll write here reason. Question 19 answer. Fuse. Fuse, it's an application. Fuse wire is tin and lead. Alloy is used. Alloy is used. Tin lead alloy is used here. And why reason is, reason is, what is the reason? This alloys which has a higher resistivity value, because of a higher resistivity value, as high current comes, heating effect, Joule's law, heating effect, so that it will melt. Because of high temperature, it will melt. Reason is high resistivity, and low melting point. Low melting point. These fuse wires which must have low melting point and a higher value of resistivity. Then what happens? As a high current comes, because of higher resistivity, more heat will produce. As heat produces, because of lower melting point, fuse wire will melt, circuit breaks, it protects our costly equipments. That is the purpose of using a fuse here. Hope you got this point. Application of fuse and what kind of material used in a fuse and what is the reason that material we have to use. Okay, hope you understood this. If you are not understanding any queries, you can put in comment section. I will clarify that. Next question is 20, question number 20 here. Two lamps are there, two lamps. One is rated 100 watt to 20 volt. Another is 60 watt to 20 volt. Are connected in parallel. See, read carefully here. Read carefully. Two lamps are there, two bulbs I'll take. One is 100 watt to 20 volt. Another is 60 watt to 20 volt. Connected in parallel to electric mains supply. Okay, connected in parallel here. Find the current drawn by two bulbs from the line if the supply voltage is also 220 volts. Hope you understood the question. Here what is given? Two bulbs are given. One is a 100 watt bulb, another is a 60 watt bulb. Its rating is 220 volt only. They are connected in parallel and supply voltage is 220. What I have to find? Total current drawn. Total current drawn. I'll write the circuit diagram for that. There are two bulbs, one bulb there and another bulb. They are connected in parallel, another bulb connected in parallel, and this then connected to a battery of a supply voltage is 220 volts. And this rating of these two bulbs are, what the rating of bulb? 100 watt and 60 watt. That is here 100 watt bulb, here 60 watt bulb. Is it correct? 60 watt bulb. Okay. Now what is the circuit current? Total current I have to find I. Total current I is equal to I1 plus I2 we can write. That is the total current I. First see, by reading question you understand Shobita. What is that Shobita? Shobita, see, don't comment like that, students, please. Ishwar Shankarappa. Don't comment like that. If you have any doubts, that only you ask here in this platform. Okay. Here total current I is I1 plus I2. I1 plus I2 is the total current. Okay. First you should understand what is the question, given question. Then draw proper diagram for that. Then you analyze what we have to find. I total current I we have to find. How to get I1 plus I2. Can we get I1 and I2 here directly? Can we get I1 and I2? No need of resistance, right? Without resistance calculation also we can calculate. Shortest method, I have to prefer a shortest method here. As much as easy method, shortest method I will use here. See, power rating is given. What is the voltage across these two bulb? Parallel combination. Parallel combination. Then what is the voltage across each bulb here? Each bulb voltage across each bulb is 220 volt only, right? Voltage across each bulb is 220 volt only. Why? They are parallel combination. Parallel combination here. So that what is the I1 and I2? This I have to find first. How to get this I? Using a power. Power P is equal to V into I. I equal to P by V. I equal to P by V. I equal to P by V. Substitute here first power I1. I1 is a power P. P is 100. P is 100 divided by what is the V? Voltage across each is same 220. 220. And next I2. I2 is equal to power. Power is 60 by 220. No need to simplify there. I will substitute here. That is 100 divided by 220 plus 60 divided by 220. That is 220, 160. 160 by 220. 160 by 220. This is the total circuit current. 160 by 220. This you can simplify. 160 by 220 is 0, 0, 16, 4, 16, 4 fours, 5.5, 4 by 5.5, 4 by 5.5, correct? Is it correct? 4, 5.5. This will be nearly 0.5.57, I think 72 nearly. Is it correct? 0.72 something? Yes, that is correct answer, right? Is it correct? Yes. This is the answer for that question. This is the answer for this question number 20 here. Two bulbs connected in parallel. First you read question once or twice. You understand what is given in that question. Once you understand, then substitute or draw proper circuit diagram here. Draw proper circuit diagram. Then what we have to find, and then how to find, that we have to analyze. That is the way of solving these kind of questions. Okay. Okay, students. Yes. Next, I go for next question. Next question. These are MCQ questions. MCQ question appeared in CBSE board exams. See, what is given here is simple question. The maximum resistance which can be made, using 4 resistors, each of 2 ohm is. Direct answer. See, there are 4 resistors, each of 2 ohm. What is the maximum possible value of resistance? Series combination we have to write. In a series combination, equivalent resistance is maximum. In a parallel combination, equivalent resistance is minimum. Is it clear? Now here I have to connect in a series. If you connect 4 resistors in a series, how much we get? 2 plus 2 plus 2 plus 2. This is the equivalent resistance. 2 plus 2 plus 2. That is 8 ohm. 8 ohm is the answer here. 8 ohm. This is the 8 ohm is the answer. 8 ohm. Yes, that is a direct question. Everyone can solve this. Right? Yes. Next, next question is 2 bulbs of 100 watt and 40 watt. 2 bulbs of 100 watt, 40 watt are connected in series. That is, one bulb and another bulb, they are in series. This is 100 watt, and this one is 40 watt. 2 bulbs are in series. Okay. The current through the 100 watt bulb is 1 ampere. This current through this 100 watt bulb is 1 ampere. Current through 100 watt bulb is 1 ampere. What is the current through 40 watt bulb? What is the current here? Current through 40 watt bulb. Students, can you answer this? Direct. No doubt in it. This is a series combination. In a series combination, what is the basic concept? In a series combination, current through each device is the same, right? In a series combination, current through each device is same. It may be bulb or any other device. Current through each device is same. If current through 100 watt bulb is 1 ampere, what will be the current through 40 watt bulb? That also 1 ampere. Sorry, 1 ampere only. 1 ampere only, correct? 1 ampere is the answer. 1 ampere. Is it clear? Yes. Next, one more question here. A very simple question. A student plots VI graphs. This is a current here and voltage along x-axis. Voltage and current graph is given. Sample of nichrome. Resistance is here R1 here, R2 here, R3 given. Choose from the following statements holds which one holds the correct option here. That is, which one is higher, that we have to identify. What is the slope of this VI graph, students? What is the slope of VI graph? You know that Ohm's law, V equal to I into R. V equal to I into R. V by I is equal to resistance, right? V by I is resistance. Here I versus V. What is the I versus V? I by V is equal to 1 by R. I by V is the slope, correct? This is equivalent to slope. Slope of I versus V graph is 1 by resistance, we get 1 by resistance. Now this graph has a lower slope, right? This graph, you look at this graph, if you have three graph here, this graph which has a less slope, and this graph which has a large slope here, and this one is in between. If I compare this graph R2, that is a slope here. Here slope is less. Here slope is high. This slope is less. This slope is high, right? Correct? Then what is the order? Slope is less means resistance is higher value. Now slope is equivalent to what happens? Slope is inversely proportional to resistance. Resistance is inversely proportional to slope. Slope less means resistance is high, right? Reciprocal. Slope less means resistance is high. Now here slope is less means resistance is high. That is, this resistance is high. This is low. R3 is low. Order, what is the order? R2 is greater than R1, greater than R3. This is the order, right? Who is given correct answer? D. Option D is the correct one. Option D, Ankita Naveen, given correct answer. Option D is the correct answer here. Is it clear? That is same question. Next, one more question here. One more question. An electric network, resistors are shown in the below. Supplied voltage is 12 volt here. 12 volt supply is given. This is a 12 volt supply. Here 6 ohm, 3 ohm resistors. See, I will redraw here. This is a 2 ohm resistor here. Next, 6 ohm resistor. Another 3 ohm resistor. This is connected to a battery with a key. This is 12 volt battery. This is a circuit. Okay. Question is effective resistance between A and B. This is a point A. This is point B. What is the effective resistance? Equivalent resistance. We have to find equivalent resistance. What is equivalent resistance? So first you calculate this parallel combination. Next in series. This parallel combination. What is the effective resistance? 6 into 3 by 6 plus 3. That is 2 ohm is the equivalent. 2 ohm is the equivalent. Now this 2 and this 2 in series. So that what is the equivalent? R across AB is equal to 2 plus 2, that is 4 ohm. That is the answer for question A, right? Answer for question A, 2 plus 2, that is 4 ohm effective resistance. Next question is current flowing through resistor of 6 ohm. What is the current flowing through this resistor? I1, I write I1. This is the main current I, What is the current through this I1? 6 ohm resistor. This current I have to find. This current. How to get this? We have a different method. If you come to PUC level, we are using a branch current principle. One is there, but I am not going to use that branch current principle because it is not in your 10th level. In your 10th syllabus, according to your 10th exam point of view, how we can simplify this? In a PUC, we are using branch current, easily we get. But here also I will use another method, easy method, to get current I1, current I1. What is the equal in total resistance, students? Here, what is the total resistance of this combination? 2 ohm, right? 2 ohm. And what is the resistance? Another resistance here, 2 ohm. 2 ohm. What is the supplied voltage? 12. 12 volt is the supply. 12 volt supply. Here 2 ohm, here 2 ohm. What total? Total. I'll write this equivalent circuit as 1 2 ohm, another 2 ohm connected to a battery of 12 volts. 12 volts. This is 2 ohm now. This also 2 ohm equivalent. Now what should be the voltage drop here? 6 volt, and here also 6 volt, right? Because identical resistors. Here 6 volt, here 6 volt, right? That is, what is the voltage across this combination here? 6 volt is the voltage across this combination. Now what is the voltage across 6 ohm? Is a 6 volt. What is the I? What is I1? Here I1 is equal to 6 by 6 V by R. 6 by 6 is 1 ampere. 1 ampere. Yes, someone given correct answer there. Correct answer you are given. Some of you are given correct answer. This also appeared question. CBSE appeared question. This one. Okay. Students, these are the some of the appeared questions I have solved, and I think this almost all concepts I have covered. In the next my session, I will going to discuss about next topic, that is the magnetism topic is there. I will discuss that, and at the end, before your annual exams, I will discuss together entire complete question paper, physics all questions I will discuss once again. Okay, thank you.